Hi, this is Vamsi Mudila. I will be discussing about derivatives and most importantly, the rules of derivation. Now, coming to the introduction. Derivatives are a fundamental tool of calculus. These have their roots in ancient Greece and also were initially denoted by the Greek alphabet capital delta. The history of modern derivatives is a bit controversial. In the late 17th century, many European mathematicians discussed the idea of derivatives. There are two main founders who provided independent and unified approaches for the concept of derivatives. They are Sir Isaac Newton, an English physicist, and Gottfried Wilhelm Leibniz, a German mathematician. These both worked individually on derivatives and calculus and used it for their own field of work. The basic concept of derivatives is that it tells us about the slope of a function at any point. The process of finding derivatives is called as differentiation. This is usually denoted by f dash of x or d by dx. These are few of the important and basic rules of derivation. The constant rule denotes that the derivative of a constant is 0. As you can see here, c is a constant. The line rule denotes that the derivative of x is 1. The constant multiple rule is similar to the product of two above two rules. The constant is taken out of the derivative and the derivative is only applied for x. Then the derivative of this equation becomes the constant itself. The power rule is one of the most important rules in the derivatives. I will be discussing an example related to this in the next slide. The derivative of x power n is n into x power n minus 1. The sum rule and the difference rule are quite similar. These rules state that the derivative is applied individually on both the terms u and v, and the sign between them remains the same. The product rule denotes that the derivative for the product of u and v terms is v into derivative of u plus u into derivative of v. The quotient rule denotes that the derivative of the terms u by v is v into derivative of u minus u into derivative of v whole divided by v square. This is a derivation example which uses few of the rules of derivation discussed in the previous slide. Here f of x is equal to 4x cubed plus 3x square minus 2x plus 1. We apply the derivative to the whole equation in order to get the derivative f dash of x. Here, the first term and the second term are in the form of a sum rule. The second term and the third term are in the form of a difference rule. And the last term 1 is in the form of a constant rule. And x cube, x square and x are in the form of x power n. So that's a power rule. So after that, we take the constants out and we apply the derivative only to the x terms. So after doing that, we get the derivative of f of x, which is denoted by f dash of x as 12x square plus 6x minus 2. Basic applications of derivative is to determine the rate of change of a quantity with respect to another changing quantity. And also it determines the maximum, minimum or saddle points of a function. It also determines the concavity and convexity of a function. When coming to data science, derivatives are used by machine learning for solving optimization problems. Optimization algorithms such as gradient descent use derivatives to decide whether to increase or decrease the weights in order to increase or decrease any objective function. Now, let's consider this dataset in which marks and streams of the student is given and the stream of student 1 and 2 is given but not of the student 3. Here, by using derivatives, we can analyze the marks and streams of student 1 and 2 to determine the stream of student 3. These are the references which I followed, and thank you.